We're going to be doing mole conversion problems using the method of dimensional analysis. Some materials that you're going to need before we get started. You're going to need your chemistry notebook and you're going to need a pencil, but then 2 additional colored pens or pencils or markers or highlighters, whatever you want, so that we can highlight certain things in our notes today. So go ahead, hit pause, gather your materials, and come back. Alrighty, for each one of these problems that we solve today, we're going to first write down the question. We're going to complete the mole conversion factors, and we're going to use dimensional analysis to solve the problems. Finally, rounding our final answers for 2 decimal places, putting appropriate units on our final answers, and circling our answers. All right. Please write down question number 1 along with the box that you see here of your mole conversion factors. Hit pause and come back when you're ready. All right, so the first step in dimensional analysis or any conversion factor is to identify what you're given, what's your starting point, and then what you're trying to turn that value into, what's your ending point. So I always like to underline our starts. So we are given a starting of 84 grams of calcium hydroxide, and they would like us to convert this into moles of calcium hydroxide. So I underline my starts, I box my ending units. That just kind of helps me out when I solve these problems. You should also have written down this box of mole conversion factors. And these are conversion factors using the unit of mole. And mole is just a unit in chemistry to say the amount of substance, the amount of stuff that is present. 1 mole of anything is equal to 6.02 times 10 to the 23rd particles of that thing or that substance. Particles can be atoms or they could be molecules. It just depends on the substance that we're talking about, or we can just say generically particles. So for us, in this problem, 1 mole of calcium hydroxide is equal to 6.02 times 10 to the 23rd particles of calcium hydroxide. Please make sure you write that down. Another mole conversion is between moles and grams of the substance, and this is known as the molar mass of the substance. It's how many grams of the substance is inside of 1 mole of the substance. And the way that we calculate that is using the chemical formula and the periodic table. So our chemical formula is calcium hydroxide. Inside of calcium hydroxide, there is 1 calcium. And so I'm going to take 1 and multiply it by calcium plus the amount of oxygens present. Now, if you look very closely, oxygen is inside of parentheses. It has a subscript of 1, but the 2 after the parentheses means you need to multiply all subscripts inside by 2. It's like distributing that 2 inside. So for oxygen, there's 1 times 2 oxygens, and so that gives me 2 oxygens present in the formula. And then I do the same thing for the hydrogens. There are 2 hydrogens present because the subscript inside is 1, the subscript outside is 2, so 1 times 2 gives me 2. And so now for the numbers, what do I plug in for calcium, oxygen, and hydrogen? That's going to come from the periodic table. So I'm going to go to my periodic table and find these elements. Alrighty, so calcium has a mass of 40.08. Oxygen has a mass of 16, and hydrogen has a mass of 1.01. So those are the numbers that we're going to plug into our equation on our paper. So we have plugged in the values from the periodic table, the masses of calcium, the mass of oxygen, and the mass of hydrogen. Now I'm going to calculate all of this, and we're going to get a molar mass of 74.10 grams. So that means 1 mole of calcium hydroxide is equal to 74.10 grams of calcium hydroxide. Okay, so if I have 1 mole of calcium hydroxide, I know it's going to have a mass of 74.10 grams. So please make sure before we move on that you have both of these mole conversion factors written down. All right, so now for the work. So we're going to take our start and we are going to write that with the unit and the chemical formula. So everything I always write always has a number, a unit, then the chemical formula. Then we're going to put that over 1 as we've practiced, and we're going to need to multiply it by one of the conversion factors from above. And since my start is grams and my end is moles, it makes the most sense to choose a conversion factor that has both of those units. And that's going to be the second one. 1 mole of calcium hydroxide is equal to 7.10 grams of calcium hydroxide. So grab one of your colored markers or colored pens or highlighters, whatever you chose, and put a colored box around 1 mole calcium hydroxide is equal to 74.10 grams. And I'm going to now take that conversion factor and write it as a fraction in my dimensional analysis, but I know my units have to cancel out. So I have to put the grams of calcium hydroxide in the denominator, and the number that I just boxed in red in front of grams was 74.10. And so now I put 1 mole on the numerator because 74.10 grams of calcium hydroxide is equal to 1 mole. And I'm going to take that same colored pen or highlighter and put the same colored box around that conversion factor in my dimensional analysis work. That just kind of lets me know where I got that conversion factor from as I'm going back and looking at my notes for reference. We see here grams of calcium hydroxide will cancel out, and we have the unit of moles of calcium hydroxide left in the numerator. That was my ending unit. There it is. I'm done with the work. Now I can calculate this answer. And remember, we're going to multiply the top, so it's just 84 on top. And then we're going to multiply the bottom, it's just 74.10, and then we do top divided by bottom. We get an answer of 1.13, rounding to 2 decimal places. And don't forget to bring over the unit from your dimensional analysis, what our ending unit was, and it is moles of calcium hydroxide. Again, everything always has a number. It always has a unit, and it's going to have a chemical formula. Question 2. Go ahead, hit pause, record the question, and record your mole conversion factors. But this time for the mole conversion factors, let's see if you can fill out the blanks here, and then come back and check your answers, and we'll work out the dimensional analysis together. Okay, so we're identifying our start and we're identifying our end. We are solving for particles of zinc bromide. So that's our ending unit. And we are starting with the number they gave me in the problem is 0.621 moles of zinc bromide. And now for the conversion factors. Maybe you try this one on your own. Let's check for your understanding. 1 mole of zinc bromide is equal to 6.02 times 10 to the 23rd particles of zinc bromide. Again, that number never changes. That number always is associated with particles, and it's always equal to 1 mole, no matter what chemical formula you're given in the problem. Now for 1 mole of zinc bromide, that's going to be equal to the mass of 1 zinc atom plus the mass of 2 bromine atoms, because I'm looking at the chemical formula. There's 1 zinc and 2 bromines. And now I look at the periodic table. for zinc and for bromine. Zinc has a mass of 65.38 and bromine has a mass of 79.90. Those are the numbers that we're going to plug in. After I plug in those values, we get an answer of 225.18 grams. So 1 mole of zinc bromide is equal to 225.18 grams of zinc bromide. Again, this value is called its molar mass because it tells me how many grams per mole of substance. Now for our work. You're going to take your start, 0.621 moles of zinc bromide, and we're going to put that over 1. You're going to multiply that by a conversion factor. And so now looking at my start unit of moles, my end unit of particles, I examine my 2 mole conversion factors, and it's the first one that we're going to use because that is the one that has the start and ending units for this problem. So please grab your second colored pencil or colored marker and put a box around the first conversion factor, 1 mole equals 6.02 times 10 to the 23rd particles. And that's the one that we're going to have to use here in our dimensional analysis. I know that we're going to have to put moles on the bottom because we need the moles to cancel out. And that's 1 mole from that yellow box. Okay, look at the number in front. It just says 1 mole. And that's equal to 6.02 times 10 to the 23rd particles of zinc bromide. And so again, I'm going to take that same color, yellow in my case. We are going to put a box around that entire conversion factor so I know where I got that from. The moles of zinc bromide got some in the top and some in the bottom, so they all cancel out. And the unit that is left is particles of zinc bromide. And I go back and look at my original questions. There's my end. Yes, I wanted to solve for particles of zinc bromide. So now I know that we're done. Now it becomes a calculation. And you're going to want to take 0.621 and times it by 6.02 times 10 to the 23rd. But remember, 6.02 times 10 to the 23rd is scientific notation, and you want to use parentheses in your calculator. So let's take a look at that. So we're going to type in 0.621 times parentheses anytime for scientific notation, and it's 6.02. Find your EE button, mine, it's second comma, and then 23 for the exponent. Close parentheses, and I get an answer of 3.74, rounding to 2 decimal places. And then don't forget, at the very end, always double check to make sure this is non-scientific notation. This one says E23, so that does mean this scientific notation. It means times 10 to the 23rd power. So my answer is 3.74 times 10 to the 23rd power, and then I'm going to take those units and the chemical formula and include that in our final answer. Again, I'm getting those units from my end of my dimensional analysis, particles, zinc bromide. All right, question number 3. Again, hit pause, record the question, record your mole conversion factors, and again, this time you try to do the mole conversion factors all on your own. The starting value is 53.9 grams of C3H8, or you can say trihydrogen octahydride. That's our start. And you're solving for particles of this substance. That's your end. And let's complete those mole conversion factors. So you have written this on your paper. 1 mole of C3H8 is equal to, you probably guessed it, 6.02 times 10 to the 23rd particles of C3H8. 1 mole is equal to a certain number of grams, and this is where we have to use the periodic table. Our formula is going to be 3 atoms of carbon plus 8 atoms of hydrogen. And we're going to look at the periodic table and calculate that. Carbon has a mass of 12.01 and hydrogen has a mass of 1.01. So we have 3 carbons multiplying by 12.01, and then our 8 hydrogens are being multiplied by 1.01. We get a mass of 44.11 grams, and so that's equal to 1 mole. All right, so now hit pause. I want you to try this dimensional analysis problem. Again, taking your start of 53.9 grams of C3H8 over 1, and then multiplying it by a conversion factor. And then come back and see if you solved it correctly. Now, if I have my start of 53.9 grams of C3H8, I know something about dimensional analysis that the units have to cancel. I have to use that same unit in the denominator. And so I need to use a conversion factor that has grams in it. So usually, if I have a conversion factor that has my start unit and my end unit, boom, there's my conversion factor that I'm going to use. But this problem is a little different. Because my start is grams and my end is particles, and I look at those two conversion factors, there is no one single conversion factor that has both my start and my end unit. And so this is going to be a multi-step problem. We're probably going to use 2 or more conversion factors. So let's just take a look here. I identify that the second conversion factor has the word grams in it. And so again, following my color scheme, I'm going to put a box around that conversion factor. And we are going to put the 44.11 grams C3H8 in the denominator because I know that has to cancel. And all of that is equal to what I put on top, 1 mole of C3H8. Putting my red box around that so I know where I got that conversion factor from. I see here that grams of C3H8 will cancel out, and I'm not done because my end unit is particles of C3H8. So I got to go one more step and see if I can find another conversion factor that will help me out. And since now the unit in my work that is left is moles of C3H8, and I'm trying to convert this over to particles of C3H8, I need a conversion factor that has both moles and particles. And that's going to be the first conversion factor. Again, following my color scheme, we are going to put a yellow box around that first conversion factor. 1 mole is equal to 6.02 times 10 to the 23rd particles. Again, I know 1 mole, that same unit has to go down and across because I need to cancel. And that is all equal to 6.02 times 10 to the 23rd particles of C3H8. I know it's a lot to write, guys, but trust me, it's going to help you keep your work organized, your brain organized in what you are solving for. Units are the key here. Go ahead and put that yellow box, well, yellow in my case, it might be a different color for you, around that last conversion factor. You see here that moles are going to cancel out. And now I have the ending unit here in that top row. Okay, I'm solving for particles of C3H8. So that's how I know that I'm done setting up the dimensional analysis. Now it's time to calculate. All right, the top row, 53.9 times 6.02 E23 gives me an answer of 3.24 E25. And now we need to divide that by the bottom row, which was an answer of 44.11. So we get an answer of 7.36, rounding to 2 decimal places. And again, My calculator is telling me E23, so that is going to be times 10 to the 23rd power. So my final answer, 3.36 times 10 to the 23rd. Again, particles, C3H8 was my ending unit. Question 4. Last one. Please hit pause, record the question, complete your mole conversion factors, and then try solving this one from start to end all on your own. Then come back and check your work. All right, check for your understanding. You are solving for grams of ammonium phosphide. That's your end. And you're given a starting quantity of 7.82 times 10 to the 22nd particles of ammonium phosphide. For your mole conversion factors, you should have written down 1 mole of ammonium phosphide is equal to 6.02 times 10 to the 23rd particles of ammonium phosphide. For the second conversion factor, you should have 3 nitrogens, because remember, everything on the inside, their subscripts get multiplied by the number after the parentheses. So for this one, it's a 3, so nitrogen is getting multiplied by 3. Plus, now for the hydrogen, you're going to do the same thing because hydrogen's on the inside. You're going to take that 3 and you're going to multiply it by the 4. And so 3 times 4, that's 12 hydrogens. And then finally, there's 1 phosphorus in the chemical formula. Now for the periodic table. I've plugged in the masses for each one of these elements. I'm getting those masses from the periodic table, and we get a total of 85.12, and that'll be grams. And so 1 mole ammonium phosphide has a mass of 85.12 grams, or a molar mass, as we say, of 85.12 grams per every 1 mole. Please hit pause if you truly have not tried solving this problem all on your own. All right, so take your start. 7.82 times 10 to the 22nd particles of ammonium phosphide. All of that is over 1. And then now for the next conversion factor. I've chosen to use the first conversion factor because that's the one with the word particles in it. And I know I had to have particles in the denominator in this next step. And so it's this one with a yellow box around it. Again, doing this for emphasis so I know where I got that conversion factor from. Particles, ammonium phosphide, cancel out. And now I'm going to need another conversion factor because right now in my work, I have moles of ammonium phosphide. However, my ending unit needs to be grams of ammonium phosphide. So we're not done yet. So let's put in another conversion factor. Okay, my next conversion factor is the one that I've been putting a red box around, and that's because I need to convert these moles into grams of ammonium phosphide, and that's exactly what that molar mass, that red box, is going to do for me. So 1 mole of ammonium phosphide, moles cancel out, and I'm left with grams of ammonium phosphide here in the numerator. That's how I know that I'm done. And it's time to end the work, pick up the calculator, and calculate our answer. Okay, so we're going to multiply the top row, and we get an answer of 6.128 times 10 to the 24th. Then you're going to need to divide that answer by the 6.02 E23. Remember, please parentheses around all scientific notation values, and you get an answer of 10.18. Hold up. Oops, I forgot something. Okay, hold up, back up. erase. Start that one over again. Sorry, I forgot an 8. 7.82 second comma for my E. 22 times 85.12. Okay. Top row gives me an answer 6.66 times 10 to the 24. Now divide that answer by the parentheses 6.02 E23. Okay, that looks better. So 11.06 is our final answer. 11.06 grams ammonium phosphide. That would be my final answer. And again, following my units, I know that the unit that was left in my dimensional analysis was grams, and that is why my answer is in grams. So a couple of keys to success for dimensional analysis. Identify your start, identify your end, write down your mole conversion factors, put units in your dimensional analysis work, and make sure you put parentheses around scientific notation and you are multiplying the top row, multiplying the bottom row, and then doing top divided by bottom, and then finally rounding answers to 2 decimal places for right now and putting appropriate units on your final answers.